Okay, now we want to talk about why water is a key molecule in life. So we need to understand the structure of water because that's going to explain all of its chemical properties. So water is H2O. So that means it's got one oxygen and it's going to have two hydrogens attached to it. And the oxygen is going to be in column number 6, so that means it's going to have 6 electrons, 1, 2, 3, 4, 5, and 6. Hydrogen's in column 1, so it's going to have 1 outer electron, so let's use an X for that. Okay, now hydrogen, its magic number is going to be 2, so it's going to see these 2 electrons and is going to want to have them. And so this hydrogen over here is going to see these 2 electrons and is going to want to have them. But oxygen, its magic number is 8. And so oxygen is going to see all of these electrons and it's going to want them. And so it's going to be a tug of war between hydrogen and oxygen on these electrons over here and then these electrons over here, because they both want to have them. Oxygen, though, is bigger. It has more electrical pull, so that means that these electrons are going to spend more time around the oxygen than they are around the hydrogen. So let's redraw it over here. Oxygen, and then hydrogen, and then hydrogen. And the electrons are going to spend more time around the oxygens, so that means this end of the molecule is going to be negative. And then this end of the molecule over here is going to be positive. So we say that this molecule is polarized. It's got 2 poles. So like a magnet has a north pole and it has a south pole, this water molecule has a negative pole and it has a positive pole associated with it. Okay, now you might also be wondering, well, why are the hydrogens sticking out the way that they are? Okay, well, this gets back to chemistry, and we said that it's the most stable when it's got 8, and then they tend to pair up, so that would mean that you've got 4. So 8 divided by 2 is 4. They want to get as far away from each other as possible, these groups. And so that's the reason why these hydrogens are in the position where they're at. And so they kind of make legs that come out like that. All right, not important. So the important thing is that water is going to have a positive end and it's going to have a negative end. So what difference does that make? So if you have another water molecule, so let's say that there's another one over here, then what will happen is that the hydrogens over here, and remember this part of the molecule is positive, is going to be attracted to this negative of this oxygen over here. So now you've got 2 water molecules that can stick together to make a liquid. And so under room pressures and temperatures, water can be a liquid, which is a very good thing because here on Earth, it just so happens that we have the right temperatures and we have the right pressures to allow water to be a liquid. So on other planets in our solar system, it's either too cold or it's too hot or there's not enough pressure to allow liquid water to exist. Okay, then another thing is that water can dissolve things. So in the picture there, you've got salt, and salt is sodium chloride. So what can happen is that the water molecule will see the chlorines in the sodium chloride, which are negative, and the hydrogens will attach to them. So the hydrogens part will surround the chlorine, and then the sodium part, which is the positive part, will be attracted to the negative end of the oxygen parts. So notice that water can surround the chlorine and water can surround the sodium, and it can pull the sodium and the chlorine away from each other. So it has dissolved the salt. And so there's going to be a lot of materials inside of your body that can be dissolved in water. So most of the chemical reactions that take place in your body are a result of water interactions. Another thing is that water can store energy. So one way that water stores energy is that water moves around as a unit. So it's got kinetic energy. So energy can be stored in the motion of the water molecules. Another thing that can happen is that those oxygens can vibrate like this. And so that stores more energy. Another thing that can happen is the water molecule can spin. So it can store more energy. So the point is, water stores a lot of energy. This is very important because we talked about how water moderates climate. So there's a picture of an island, and so energy from the sun that normally would be heating up the island, that energy is being stored in the water that is surrounding the island. So that means that that island is going to be cooler during the summer than it normally would be. Then during the winter time, when that island should be cold, the water then will give off its heat, and then that heat can blow onto the island, and it's going to keep it warm. So any world that has lots of water is going to have a moderated climate. It won't be too cold and it won't be too hot because of the effects of that water. And then one more thing is that water floats when it freezes. So what can happen is that these water molecules, when they start getting closer and closer and closer together, as they're about to freeze, they form hexagons. So when in elementary school you made snowflakes and you had to fold the paper and then you cut it and you opened it up again and then that made a snowflake, did you ever notice that they were six-sided snowflakes? And that's because of the particular way that these different atoms will orient themselves. Well, do you see how it kind of makes an open space in between the water molecules? And so that open space is going to decrease the density of water to the point at which it will float. So frozen water floats on top of liquid water. And this is very, very important because let's say that you have a lake that has some fish in it, and then it gets really, really cold. So what will happen is the top layer will freeze over, and then that's about it. So the fish underneath the ice are okay. But let's say that you had a different substance that when it freezes, it became more dense. Then what would happen is that layer of ice would drop to the bottom of the lake, and then a new layer of ice would form at the surface, and it would drop to the bottom of the lake until finally the lake would just be full of ice, and it would never thaw out. Well, maybe during the summertime, the first few inches of the water, of the material on the top, would turn into a liquid. So it's a really, really good thing that when water freezes, it floats and it makes a surface, and then that protects anything that is underneath it. All right, so let's now go and when we come back, we're going to talk about how complicated is life.